All right, hey guys, I wanted to talk a little bit more about lessons 10 and 11 with you because I think it was a lot to cover. So again, this video is going to cover the recap of lessons 10 and 11 from Unit 2. Okay, so we covered a couple of main ideas. One was the idea of looking at graphs, and the graphs could be in two different equations. One of the equations was ax plus by equals c. This was called standard form. Okay? And then we also talked about an equation called slope y-intercept form. So we just say slope intercept form. Okay? And the nice thing is in standard form, you've seen questions like this. This might be questions where you're like purchasing two different items and they have different prices. So you may have seen ones where it's like, you have maybe each hot dog is $2 and each, fry is $1 and you can spend $10. That's a good example of a standard form type problem. And then a slope intercept form problem might be something like I have $20 in my bank account and I add 5 every week. So see there, you can see that. So it just depends kind of what problem you're dealing with which one is better. Okay, so let's look at slope intercept form for a second. Slope intercept form, the slope is m, and this tells us how much we change vertically so how much the y-axis changes versus the x-axis. So we'll look at that a little bit more. And then the b value is literally your vertical intercept, or usually that's called your y-intercept because it's when it hits the y-axis. Okay. And so we're going to be able to our lines can be written in both forms. So that means if you have it in this slope intercept form, you're going to be able to get it in standard. And if you have it in standard, you're going to be able to get it in slope intercept form. So we're going to do a little of that, the converting part. But first, in our graph, we looked at how to get that slope intercept form from a graph. So let's look at that. So I've done a couple of examples of graphs here. So in this first graph, so first we would want to get our slope. And so you can do your slope in a couple of different ways. You can find, usually we start, here's our little, this is actually our y-intercept, so 6. So I'm actually going to get the b value first. So I got 6, that's where it hits my y-axis. $6 to be exact for this one. To get your slope, you can either go over 1, at a time if it's easy to do that. So 1 is how much you're changing in your x-axis. So for every 1 day, let's see how much we go up. So if we go over 1, we end up right here. And that point is, careful, this axis is going by 3s. So this would go up to 9, which means you went up 3. You're not saying 9, you're saying how much you change. So you went up 3. So your slope is the fraction you went 3. You went up 3 in 1 day. So that means you're going to change by $3 for every day. Right? So you're going to change $3 per day. You're going up or increasing by $3 per day. So then if you want to write the equation, guys, y equals mx plus b, you can literally just plug in the slope you found, 3x, plus your y-intercept. Boom, you're done. Let's look at another graph. Here, if I want to get my slope, or actually my y-intercept is easier to get, that's what I start with. So if I go up on my y-axis, it looks like my y-intercept is $24. So maybe I start with $24 because that would be at 0 days. Now for my slope, if I go over 1, so here's 1, then I change, let's see, this time I went down. So I'm going to be negative, and to go from 24 to 18 is -6. So my slope is going to be, I went down $6 for every 1 day, right? Because you went 1 day over. Okay, so that means your equation would look like your slope, -6x, because your slope is what's in front of your x, plus your y-intercept. So there's your equation. So again, what does my slope mean? Because this is where the book and your formative and your practice problems will ask this. What does the slope mean? The slope is as I increase each day, so as I go up one day, the amount of money for this one decreases by $6. So each day you add, you go down by 6. For this graph, what happens? Well, for this graph, for every day I go up by 3. So you would say each day increases the dollars by 3. So as you go up each day, you're increasing the dollars by 3. Okay, let's look at another example. This one is a little bit trickier. So on this one looks like we have minutes on our x-axis. Oh, and they're going by tens, note to self. See, 10, 20, 30, 40. And then calories burned. Okay, so my y-intercept, or my calories burned initially, is 20. So maybe I've already started with some calories burned for the day, and now I'm going to burn some more while I do some exercise. Now, to get my slope, this one is a little tricky because we can't go over just by 1. That's not easy to do because this graph isn't set up that way. So here's another way that you can get the slope. Pick 2 nice points. So like I'm going to pick 20, and then see how this point right here lands perfectly where those 2 meet? I'm going to use that. Okay, so if so, I need to know how much I change in my x direction. That's going to be on the bottom. And then I need to know how much I'm going to change in my y direction. That's going to be on top. So let's see. Let's do the y direction since that part's the one that's on top. So in the y direction, I went from being at 20 to this point is up at, what is that? 30? So I'm at 30. And my change in the x direction isn't just 1. To get all the way over to that point, I have to change by how much? I went from 0 to 20, so I changed by 20. And I should reduce this fraction, guys. So I can reduce them both by 10. So this becomes 3/2. Or if you want to make it a decimal, you could say 1.5. And I am going up, so it's a positive number, right? If I was going down, I would make it negative. So my equation would be either 1.5x, remember your slope x plus b, plus my y-intercept 20. So what does my slope mean? 1.5 is the easier one to use, but you could also use this. This is saying that you burn 3 calories in the bottom 2 minutes. Or you can use this one. If it's not a fraction, you can say you burn 1.5 calories a minute. Or for each new minute, your calories increase by 1.5. Okay? How many calories have we already burned to start with? That's when you go over to the 0 and you look, oh, I started with 20. I had burned 20. And then you can like do different things with your graph, like, maybe they might want to know, well, after 60 minutes, how many calories had you burned, right? And you could say, okay, I'm going to go over to the 60. It looks like I hit my line right here, follow it over. That would be 50 calories after 60 minutes. Or they might say like, approximately how long will it take you to burn, let's say, 70 calories. Then this one we might have to estimate because it might not be perfect. So 70 is right here. No, that one looks pretty good. Looks like it would take me, follow it down to your minutes, about 100 minutes. Okay. So that's that. Now let's go back to the notes. I want to show you kind of what we were doing on the notes. So this first question on the notes is a lot like your practice problem. So it says a club is ordering t-shirts. So check it out here. If they order 1, 2, 3 t-shirts, the graph shows the relationship between the cost and the number of t-shirts. What does the slope mean? The slope, first of all, the slope should always tell you how it's changing. Like it should tell you how the y value, the cost, is changing per the x value, number of t-shirts. So that's what I'm looking for. I'm looking for something that says that. Let's see. It tells us there's a fixed cost. Oh no, slope is not fixed. So we definitely can get rid of A. B, it tells us the amount that the total cost increases. for each shirt ordered. Oh, hey, that looks right. It's telling us how much the Y value is changing for each t-shirt X. Yes, that's the correct answer. Let's look at C real quick. This one says it tells us that when 4 hats are ordered, it's 90. Guys, this is not telling you how it's changing. This is just a point on the graph. So that's not slope. That's just a point. This one says it tells us when the number of t-shirts increases by 5. So if I go from 0 to 5, then the total cost increases by $50. Well, let's see. This one sounds kind of good, but we have to see if the numbers actually make sense. So if I go over 5, let's see how much I go up. So I'm here, which is maybe, these are each 25. So maybe this is like, I don't know, maybe it's 40, we'll say. You can just estimate. And then it looks like when I go over 5 t-shirts, I'm all the way up here, which this looks, it's over 100, that's 125, so maybe it's like 110. Did that go up by 50? Oh no, that went up by 70. So there's no way D could be right because it just wasn't correct. But you're looking for that one that talks about the y-axis changing or increasing if it's going up, for the x-axis changing. Okay, how about this one? A tank is being drained according to the model, and time and minutes are expiring. So let's let's do B first. What is the y-intercept and what does it mean? Well, let's find the y-intercept. So go to the y-axis and it hits the y-axis at 200, and 200 is in gallons because that's that axis. So let me use a different color here. So 200 gallons, what does it mean? Well, this is what you start with, right? So this is when time in minutes is 0. So it's the number of gallons at the beginning. Or you could say when time is 0. Okay. Okay. So there's our y-intercept. Remember, that's like our b value in our equation. What's the slope of the graph? Oh, here we go. We got to find the slope. So the slope, I'm going to find 2 nice points. So I'm going to use these 2. And so remember, your change in your y values goes on top, and your change in your x goes on the bottom. So let's see. To go from here to here, I go down. Now careful, this y-axis is going by 25, so that makes this one 75. So this goes down 25 for the y. As it goes over, how much does it go over? Let's see, 1, 2. So the slope, I'm going to go ahead and make it a decimal, negative 12.5. I can do that in my calculator. And what does this slope tell us? Well, again, it tells us that it changes this many gallons per, what's the x-axis? Minute. So as the number of minutes increase, as I have more, each minute that goes by, I lose 12.5 gallons in the tank, right? That's because this, why is this negative? Because I'm going down. If I'm going up, it's positive. Down is negative. So then we can write our equation. Y equals, you need your slope, negative 12.5 x for each minute. That's what the x is. And then plus your starting point, your y-intercept, 200. Okay. And then this one is probably the easiest one, I think, for you guys of all of them. This one has Erica made cookies. This x-axis is how many days since the cookies were made, and the y-axis is the actual amount. So always pay attention to your axes. How many cookies were left after 6 days? I would go over to 6 days and then see where it hits my graph. Oh, 6 cookies. So again, this was telling me how many days, right? So I went to days. How many days did it take for 12 cookies to be left? This time I know the number of cookies. So I'm going to go over to the cookie axis and I'm going to go to 12 and I'm going to look, and that's where it hits, which would be follow it down. That's a 3. 3 days. Okay. How many cookies did she make to begin with? Well, that would be when no days have passed. So that would be all the way at the beginning. So how many cookies? Follow it all the way up. She made 18 cookies. And how many days does it take for the jar to be empty? Well, the jar to be empty would be when there's 0 cookies, right? So we're going to look for when there's 0 cookies, which is, here's 0 cookies. Starts at 18 and goes all the way down to 0 cookies is right here, which is 9. So it takes 9 days for 0 cookies. And the second part of the lesson was just being able to take equations and switch their forms. And so to get us ready to do that, I just want to touch base on a couple of things. If I'm dividing, I talked about this in class, multiple terms on top over something, I have to do each of them over that number. So I'm going to do 4x divided by 2, which would give me 2x, and negative 10 divided by 2, negative 5. Here, same thing. I have, for this one, I would reduce the 5 and the 25, or actually you can just multiply this out first. Let's do it like that. So I would get 5x, and then 5 times 10 is plus 50, then over 25. And then guys, I gotta write them separately. I gotta do 5x over 25. I have to divide everything by the 25. So 5, this is gonna reduce. This is a fraction. 5 over 25 reduces to 1/5. And then this is 2. You can practice that with your calculator. And then this guy down here, I'm gonna divide 1 by negative 2, and I'm gonna divide negative 50x by negative 2. Notice I'm taking that minus sign with this. This is just negative 1/2. You can leave it like that. And then a negative divided by a negative is positive, and 50 divided by 2 is positive 25. Okay, one more. I've got negative 1/5 x. I'm going to have to do both of them divided by 2. This guy's fine. You can make it a decimal if you want. And then this one you can do in your calculator, negative 1/5 divided by 2. That becomes negative 1/10. Oops, this should have been a plus symbol, sorry. So plus. Okay. So now you need this strategy to be able to do the next part that I'm going to do. Okay. So let's take a look at how to convert these. We're going to convert these equations, which notice these are all in standard form. We're going to convert them to slope-intercept form. Okay. And so I like to rearrange them. There are a couple strategies for doing this, but I like to rearrange. So let's do some of that together. So the first thing you have to do, if you want to solve for y, is move this x term to the other side. And since it's already a negative, I can cancel it out by adding 4x to both sides. So that's what I'm going to do. So this cancels. I get 3y equals 3 plus 4x. Okay. And then I have to get rid of this 3, which is being this is multiplication. So to get rid of that, I'm going to divide. This is why we practiced this a little bit ago. So now you're going to write them both over 3. I like to put it as a fraction out front. And then we always, this becomes a 1. You can leave this as a fraction, but I like to have my x term first. So I'm going to put that x term first, and then this is still a positive 1. And then I'm just switching their order, guys. So then this would have a slope of 4/3 and a y-intercept of 1. If you wanted to look at the coordinate, that would be 0, 1, because it's always 0 for the x. Okay, we'll do just a couple more. So these are the ones that we're going to do, but I have a sheet here off to the side I'll do that on. So we already did the first one. And so we said this first guy had a slope of 4/3 and a y-intercept of 1. So this was B. Okay, so I'll try just a couple more. So let's do number 2. So in number 2, the first thing I'm going to do is move this x term to the other side. And I'm going to move it by canceling out 12x by subtracting 12x. So I have negative 4y. I have 8 minus 12x. I'm going to divide by this coefficient, which is a negative 4. Don't lose that negative. That completely cancels, so you're left with y. Then I have to do 8 over the negative 4, and then minus 12x over the negative 4. Careful. I get negative 2, because a positive divided by negative is negative. Negative divided by negative gives me a positive 3x. So you could rearrange the order if you want and put the x term first and then this negative 2 second. What's my slope? 3. What's my y-intercept? Negative 2, which remember, if we write it as a coordinate, is 0, negative 2. So that one was E. All right, last one that I will do together, I'll do number 4 because it's a little weird. So let's do 4 together. So number 4 is negative x plus 1/3 y equals 1/3. So the first thing I'm going to do is move this x by adding it because it's already negative. So I get 1/3 y equals 1/3 plus x. Now this is tricky. This time we're not, because it's a fraction, I'm not going to divide to get rid of it. I'm going to multiply by the reciprocal. What's the reciprocal of 1/3? 3. And I'm going to multiply it here and here. Notice I put the parentheses around. That's so that I don't forget to distribute it on this side. So this side cancels, and I get y equals. And this side I have to multiply both of them by 3. 3 times 1/3 is just 1. And then this would be plus 3 times x, 3x. So again, you can reorder those, 3x plus 1. And then my slope is 3. My y-intercept is 1, or the point is 0, 1. So that was A. Again, you could try 3 and 5 if you wanted to on your own. Let's see, we can see which one is correct. I will tell you that if you want to try it on your own, this is D, and that makes this guy C. So if you want to try those on your own, you could do that later. Okay, all right, so good luck with the practice problems, and I'll see you in class.